For the wired plugs, there are certain standards that are used and now also protocols. Especially Dante has become very dominant in the large installed audio systems. AVB is an audio video broadcasting standard. It's a less frequent but public free standard. But generally speaking, the interfaces for microphones, for speakers, the plugs, those interfaces haven't changed for decades.
Welcome back, Florian.
Hello, Michael.
So today we're back to talk about special acoustics and the specific challenges that engineering teams face when designing and manufacturing special acoustics. So first of all, could you share about yourself for those who don't know you yet, and quickly tell us who you are?
Hello, I'm Florian Heike, founder and CEO of Selenius Company Limited, and we have been involved in manufacturing of audio products for almost 20 years. And today I'm happy to talk to you about the ins and outs of that industry.
Okay, great. So for engineering teams, what is a specific kind of engineer that is responsible for building special acoustics projects?
Well, and during my experience, I encountered quite some people that actually come from the music field, that after they became a little bit older, they have a passion for acoustics and then went into the technical section of it, whether it's the engineering part, design part, planning of audio systems. There is a kind of unique dress code. Most people in that industry wear black clothes. Yeah, those ones who are setting up the systems and those ones who are in it. But the challenge is that you have to work against a very specific deadline. Every tour, every event is scheduled long before the audio system is being set up. But by the time the event starts, everything has to be ready.
You're talking about like a concert.
Whether it's a concert or it's a stage or any other, but these are the large acoustics environment. But even for buildings, I mean, when you are like doing a university classroom, the semester start is there. That's a given date. Things have to be ready then. You cannot delay Christmas in a church. Christmas will come for sure. That's a set date, you know?
Yeah.
You work against a specific deadline.
So for special acoustics, you're talking about speaker placement in a church, speakers for a university auditorium, the concert hall. Anything else I'm missing?
Events, portable speakers, festivals, can be Formula One race, can be a public viewing of a big sports event. We have the European soccer championships right now. There's lots of public viewing places around there. Those events tend to be the driver, the decision making to invest into a new acoustic product. And the providers or the companies that are in that industry, they have to be able to deliver against these deadlines.
And they can't just go to a big electronic store and buy speakers, right? These all have specific customized applications.
Yeah, I don't think you can buy a stadium speaker at Circuit City or something. I don't think so. Yeah, and your little boombox that you have, USB boombox, will not do the job that you need in that kind of environment. So it is not an easy industry. And the companies that are active in these fields, they have been active for quite some time. Because you can't do that overnight.
Right.
It's iterations. It's not an easy industry to just jump in and say, oh, no, I do special acoustic products. No.
And how long have you been in this industry for special
Almost
acoustics?
20 years. Yeah.
Yeah.
And we are mostly serving brands that are already established players. So we are not doing our own brand. We just support companies that are already in that field.
Could you share some of the typical design and engineering challenges that you face with special acoustics?
Yeah, I think one of the major challenges that uh, engineers nowadays face is that the expectations of their customers for connectivity and for reliability are very high, because we all have amazingly well-made smartphones in our pockets. We have quite good speakers that connect well with those consumer devices. But in the professional world, you have a much smaller quantity. But you expect them to work just as seamless as the consumer equipment, where millions of pieces have been produced, where iterations of engineers had a chance to work that through. That's one of the challenges. The second challenge is that you are relying on the semiconductor industry, for whom you, as your special acoustics maker, you are a tiny client. You're not relevant to these semiconductor guys. They're not going to produce a chip for your 200 sets that you're going to build, or 500 sets that you need.
So that probably drives up the cost because it has to be niche.
Drives up the cost, but most of all, it is leading to the situation that you make a design, you spend, and by the time you finish, you have a sample of an IC, and then you say, oh, yeah, now it works, now I want to buy this. As you say, this IC has been taken end of life. Please go back to the drawing board. That's huge frustration.
End of life, so you mean...
They just finish that IC and come a new generation and may have a different package or different things, because maybe the semiconductor technology was changed or the demand was too low, so the chip maker says it's not worth it to stock these parts anymore. So the semiconductor sourcing, and especially if you design a product, you cannot design it for 1 year only, just like in the consumer space. You need to design for 5, 7, 8, 10 years down the road. But the lifetime of the components that you put in is a challenge. So I heard some engineers that they do it when they are sure about the component. They buy the component first and then complete the design, because they're afraid if they don't buy the component, all their design work is obsolete. And that's a huge challenge. It's also a financial challenge.
Do you mean they design around the component that's
Yes.
already available?
Yes.
Oh, wow.
Because they don't want to run into that problem.
Yeah. Kind of like a chicken and the egg problem.
Yeah, just there are a lot more chickens and a lot more eggs on the PCB.
Yeah.
It's not just one component.
So how important is seamless integration with existing audio systems for your engineering clients?
Yeah, this is a very important factor. And good news is that there have been some standards being established already long before the computers came on the market. So most of the professional audio systems are still using wired connections. I mean, except for the microphones, there we have, of course, microphones. And in professional applications, those microphones tend to run on non-public frequencies. Because you can imagine if you have a crowd of 200, 300 people and everybody got a cell phone, and every cell phone is running on a Bluetooth or on a Wi-Fi frequency, that's quite a polluted space in the frequency spectrum. There are some technologies where they use IR, but I often found that a little bit dodgy, because once the IR visibility range is interrupted, you get an interruption. So I heard from some of my clients that for specific areas, they even pay for reserved frequencies to circumvent that, which are then only regionally available because they don't interfere with other services. Yeah, that's also a challenge. But beyond that, most of it is wired. And for the wired plugs, there are certain standards that are used, and now also protocols. Especially Dante has become very predominant in the large installed audio systems. AVB is a audio video broadcasting standard. It's a less frequent but public free standard, relying on Ethernet connections, like the internet connections. But generally speaking, the interfaces for microphones, for speakers, the plugs, those interfaces haven't changed for decades. And that's very, very important, because that allows the interoperability of the different manufacturers' devices. So like XLR is the standard for a microphone cable. That's quite commonly applied. And it's also strong enough to carry enough signal.
So when you customize special audio solution, you're still working with certain standard.
Yes, you need to make sure that
standards.
that the interfaces because your product is not going to be standalone inside an application, you still need to be able to interact with other devices.
Okay. And what level of performance and reliability do your engineering clients expect when they work with you?
Well, because especially in professional audio, you're not going to produce the same product so frequently because you just don't have the scale. So you need to pay a lot more attention during your design work to avoid mistakes. And it's really not so forgiving because you have little chance to correct your mistakes. And that's why the people that are in that field tend to be of more advanced age, especially when it comes to analog technology. Because previously in the 1970s, 60s, 70s, 80s, all the engineering was analog. And with the involvement of the computer technology, most of the electronic engineers have emerged in the digital space. But our ear is still analog. We still need an analog signal. So even though we use digital processing, then there is still the conversion from the analog input, aka your speech, to a digital signal, then the processing of the digital signal, and then again the conversion from digital back to analog to create the wave onto that actually hits your ear. So what we learned that you have great digital engineers, software people, they can even update your system. But when it comes to the analog section of the business, there's a huge shortage of qualified staff because the folks that did the great work 15, 20 years ago, the majority retired already.
Mm. So it sounds like this is a opportunity for young people to.
I believe if a young person with a passion that's ready to go into analog engineering, yeah, go for it, because you're going to be a rare species.
And even these new digital systems, they still rely on certain analog techniques.
Yeah, because as I say, the signal, the end stage, although you have a Class D amplifier, but then the signal needs to be smoothened out and has to be filtered to make sure that you meet the regulations of EMC. That's still analog engineering. And the filters, the passive filters in the speakers, they tend to be analog filters.
Mm-hmm.
It's not rocket science, but it's still there's still a lot of skills in that. And if some of our audience are amongst the younger people that are still not so sure about which technical career they are pursuing, it's actually not so easy to find a place where you can learn that, because you have to learn from the older guys.
And they're starting to retire, I imagine.
Yeah, because the people that I'm aware of, they're all end of 50s, beginning 60s that have that kind of experience. Because to reflect to what you do on the circuit and to what you hear with your ear and how that relates, that was very prevalent during the 60s, 70s, 80s. Those engineers knew, oh, this is this noise, this him, this hiss, this, that. They have names for these kind of disturbances. But now when we are in the digital world, you have tone or no tone. It's very digital.
Mm.